Hello and welcome. I'd like to talk a little bit today about a new tool that I'm releasing called EndpointBOM. You can see on the screen here, it's at github.com/eopolsniper/endpointbomb. Basically, point of the tool is similar to SIFT, but for developer endpoints. Wanted to be able to quickly capture all dependencies that are installed on the machine, their applications, browser extensions, IDE extensions, as well as MCP servers. Just so we can gather all of that. There's been a lot of attacks this year about third-party dependencies and developers, workstations, and I just haven't found good tools that can capture that very well. So this is supposed to go out, install, run, gather data, and ship it back. I'm going to be showing today using it with an OWASP tool called Dependency Track that accepts the SBOMs that I'm creating in my tool, and then how to visualize that. And then you can use that for monitoring and alerting and things of that nature if there is malicious material. So just really quick, EndpointBOM again, repository. There are releases that generate whenever there's a new version. Releases you can go and pull down, again, similar to SIFT, they're pre-compiled. And you can run that. That's going to create your SBOMs themselves. There is another tool under deployment that you can generate yourself if you want to use dependency track. This does an automated upload to dependency track as well. You have to have a script, I shouldn't say automated. You have to have a script that runs dependent or EndpointBOM, and then this will ship them. But you have to have a script over it that runs things in order and put it on a cron job or a scheduled task or something of that nature. Kind of normal sysadminning. But for this, since you will put an API key in for a dependency track, you have to build these yourself. So you just put those in. There's easy instructions, but you put in your URL and your API key, and it compiles into Go. I try to do my best to do some obfuscation there so that nobody can get your API key back out very easily. If they spent enough time, I'm sure they could. But if you scope your API key, that's a lot of work for very little benefit. So reasonably secure, especially in a corporate environment. But really, that's kind of the two things, is you're going to have two files out of this. There's also a Python version of that if you just want to test with it and not be compiling yourself. But either works. Just the Python version is going to have your API key exposed in it. So not terribly secure to push out to thousands of endpoints. But let's take a look really quick at how this tool works. It's very simple. So if you see here, I've got it as demo folder that has a couple different items in it. So EndpointBOM is the actual tool that creates the endpoints. There's a help file. There's a bunch of different flags. Pretty much there's only two that you should probably care about most of the time. One is, do you want to look at browser extensions or not? In some cases, this will cause a pop-up for users the first time, and they would have to hit yes, or you have to run it with full disk access. If you're running this through an MDM like Jamf or something like that, you're probably going to configure it for full disk access and admin anyway. So it's really kind of a moot point. But if the user is running it themselves, they might get that pop-up box, and if you're pushing this out to hundreds or thousands of endpoints, you don't want a bunch of people complaining that there's a pop-up box and they don't know what it is. So I have that turned off by default, but you can turn it on. And then the other one is my company is a remote environment, and as I try to convince the company to push this out, one thing that I like is to know the public IPs. So this tool will gather like the host name, the logged in user, the private IPs, and then you can fetch these public IPs. I have that turned off by default because it goes out and it calls to some normal sites that admins use to see what is your public IP, but they're not owned by me. So it's up to you if you want to trust them or not, but there's three of them in there. And basically, this goes out, calls that service, and pulls back the IP. I do have strong validation on so that they can't send back something super malicious. But still, that risk is up to you, as well as, do you care? If you're in a fully internal environment, you probably don't care. So I have it turned off by default. But in my case, I am going to run this with the -- all, which both of those features I just talked about will be enabled then. So if we just run EndpointBOM space -- all, it runs and it does things. So it goes through when it's gathering. Not only does it look for global package manager options, but it does for specific local ones. I also have it going through log files. So certain managers, such as NPM, have log files that show every version that's installed, uninstalled, throughout the history of it. So I grab those and I pull those in as well, and that way, if somebody does install something that's turned out to be malicious and uninstalled it, as you're deving and testing, you're cycling through a lot of things. It's going to capture that history and put it all here in the SBOM. I haven't seen any other tools that are doing that. They just look at what is that moment in time. So thought that was a bit of a neat feature. But we see here, it ran 185 packages on my machine through different package managers, 182 applications, 7 IDE extensions slash plugins. That also includes MCP servers in that file, and then 30 browser extensions. You'll notice 4 files get generated, one for package managers, applications, IDE extensions, browser extensions. And then there's also this archive. The archive contains all 4 of these files, but it also contains any of those log files I was talking about. Those get cleared off of systems. It's very random when they clear or not. I saw some a while ago for 6 days on my machine, and I've changed nothing, and then I'm seeing them only for a day. So I package those up and keep a copy of them as well, so that they don't clear off systems. So if you want to do investigations, you can. All of these files stay on the system for 60 days by default in a scan directory, and then as you run, if they have any that are over 60 days, it auto deletes those. That is a configurable feature, but that is the default. So you have that. If you want to use this for investigation purposes later, I recommend uploading these to another server like an S3 bucket or something. So you have that, or a file share. But just so you have these for a backup, because there is some more context in the files than I can put into dependency track. But there is some fun context there for investigation. I've spent way too much time looking at third-party dependencies this year, especially with things like Shai-Hulud and things of that nature. It's been incredibly frustrating to track down and do this at scale. So that's the entire point of this tool, and I've been trying to build in everything that I wish that I could have had and made my life a lot easier into this. So we see these files. Again, there's the scan directory. That scan directory has these files. Inside of there, you will notice that there's an archive. If I haven't done an upload, then they're just sitting here. So I haven't run an upload for a couple here, he's noticed. But the archive is, once they're uploaded, they move to the archive. And that's where if they sit there for over 60 days, they clear out when the DT upload tool runs. So if we just run the DT upload tool now, this is going to upload it to dependency track, hence the DT. And we see it pulled the latest files and uploaded those and then moved them to archive. So everything looks good here. If we now go to dependency track, which if you're not familiar with dependency track, it's by OWASP. It's a great UI tool. And it's more made for CVE kind of analysis, but I'm using it for this, and I think it's going to work great. So we see here, I have no vulnerabilities in any of my items, which could be one of 2 things. First, when you admin dependency track for the first time, go to administration, go to vulnerability sources, make sure OSV is turned on, because it's turned off by default, and then set all the ecosystems you care about. Now, I will say this makes it look like you still have nothing. It takes 3 to 5 days for the first pull of this, and I'm only at day 2, I think, on this system. Had to do a reset. So it's going to take a while. So the first time, let it sit, and then it'll start picking up. Some other things, National Vulnerability Database, I believe, is turned on by default. And then you can also turn on the GitHub advisories. Both of those pull in much faster. GitHub advisories, you need a personal access token. I'm not actually sure what you need, if this can be a free one or not, to be perfectly honest, because I don't actually have a free account to GitHub. All of mine are special. So, but I think you could just use a personal. Otherwise, if you have a corporate like enterprise, I know that works because that's what I was using at one point. But just make sure those are turned on. To get your API key, that's the only other thing you really need to care about in here. It's a little bit of a weird place. So you go in, you hit access management teams, and you choose whatever team you want, or you can create a team. So if we want to do automation, you just hit API key under whatever team, and you can create one. This is the local host system I'm going to blow away after this demo, so feel free to steal my key. But then you can also set permissions. My documentation has what permissions this needs, but it's not much. It's BOM upload, view portfolio, and then one that I forget. I think it's project creation upload, but that's in the documentation if you want to scope those keys down. Definitely recommend that. But if we go again back to dashboard, you would normally be able to see the vulnerabilities and things here. What we're only caring about, at least for my thought, is malware. So if you actually go to the OSB database and look, there's a bunch of things out here. So if we go here and we go to, where's our NPM? LMN, there we go. If we go out here, we can see a bunch that are started with MAL-2025. These are malicious packages, and these are across different repositories. They have the same thing for IDE plugins and things of that nature. So really what I'm trying to track on for the malware analysis and trying to figure out, post if something got pulled in is anything with that MAL. So that's what I care about. So again, I don't really care about the CVEs in my use case. You might want to use this for a normal SBOM as well, but really all that I care about are these MAL packages. So that's what we're trying to pull in. That's what we're trying to track. And that's what the OSV database gives you. So if we go in here and we actually look, most of our stuff that we care about is going to be under projects. How my tool works is it puts the host name as the file name, and that host name then becomes the project name. So host name of your developer laptop. And then you can expand down here, and underneath you'll notice our files. I have this, by the way, sorted by last SBOM import, so the newest files are here. But you can see it keeps going. So every time you upload new files, you have your timestamp, so you can go back in time to see when things happened and keep that data. So you're going to know if something new got told 5 days later that, hey, something malicious came out 5 days ago, you have that data here, and your tool is going to alert on it because it's still going through all of those back versions, and it's going to say, hey, malware was in this version triggered. So pretty slick. But again, all of these will stack and nest under this parent project, it's called. So if we go into some of these and click here, we've got, so this is the package manager. So this is going to be npm, pip, etc. We can see under details here, every time the file runs, again, it's pulling that username, the local IPs, the public IP if you ask for it. So it's putting those, it's putting it in each subfolder. So every run. So that way, if they're changing, your IPs are going to change. It's going to capture that and give you some analysis. So if you need, hey, this malware ran and I need these IPs quick, you're going to know the locals, you're going to know the public, you're going to know what user was on it. So it just gives you something to kind of start that investigation a lot quicker. So kind of nice and easy. If we go to what actual components are here, we can click into the components and we can see all the different packages. If I wanted to search for something like ESLint, which was, I think, Shai-Hulud 1, we can look here and see ESLint, and we can see every version that's installed on the system, and all of these other kind of sub-dependencies. You can go to the dependency graph. So one of the other things that's been problematic is transitive dependencies. So you install one thing and that has dependencies, that has like 10 dependencies, and then those 10 dependencies have dependencies and how those chain down. And some of the Shai-Hulud stuff especially was multiple chains down, right? So then how do you track that back to know what actually was installed and where it came from to see who else could have installed it? So this kind of helps with that. So you can click here on the little circle and come down. And again, if we look at ESLint here, we can click on that and we can see when you install ESLint, here's all the dependencies that ESLint has. And then you can click debug, and here's what debug has. So you can go down through all of these dependencies and chain it all the way down and try to figure out. So yeah, I knew that if I'm throwing shade here on poor Concat map, but if Concat map had a vulnerability, right, malware in it, and we catch that and it's like, hey, we know this, but where the hell did that come in? We can just go here and say, okay, it was here, and we can go back up to ESLint and we can find that a little bit faster. So it makes it kind of nice again. And those details are kind of the same for each. So that was package manager. Application is going to be similar. It's all under components. So you can see your versions of different things that are installed on your system. and have that for analysis as well. And just wanted to show one or a couple different things here for IDE extensions. Again, we have 7. So again, this does IDE extensions and MCP. So if you're wondering what is the difference on some of these, like is semgrep an IDE extension or is it an MCP? You can click into semgrep here and go to that view details and extended, and I'm capturing that and putting in if it's an MCP server or if it's an extension. So it'll tell you there. Then if we go back here and we look at an extension just to show a difference, so VS Code Docker, and go to extended, and you see here it says it's the IDE cursor. So since it's not saying it's an MCP server, this is the IDE extension. So gets you a little bit of visibility on that. And then in a similar vein, if we go back here and you look at browser extensions get difficult on Chrome, especially because of profiles. So different profiles will have different extensions and they can be different versions and you don't know what's running or what's not. So we can go here and we can look, and if I go down to like 1Password and we go to view details and back over to extended, it says what browser it is. So it's Chrome, and it says what profile it's in. So I have like 5 profiles on this machine, and I had some surprising things. The one that I've forgotten about, that I don't even have in my visible. Like I can't click through it, but it's still stashed here. And I don't honestly know if those are running anymore or not. I've got to figure out how to delete that. But so it digs some stuff up. But this way you can track down too. Again, if you're looking you look and you're like, hey, but you might have to click that little dot, right? And be like switch user in Chrome and figure out, and you don't know what the user has been using. So it's good to have that. Other things, so components, again, if you just want to look quickly for like ESLint across all your machines, because so far we've just been looking at the one machine, right? And that's not very effective. But if I want to look at like ESLint and find that, I can pull that up. And specifically, I could do, let's do this version, right? And like, hey, this is potentially a malicious version. I can search that version, and it's going to tell me every single laptop that it's on because of the project over here, and it's going to show you what dates and times that was installed as well. So you can pull that data out. So very quick to parse through, and I have put massive amounts of data through this in some of my tests, and it handles very well. And I'm just running it locally. I'm not even running it on server infrastructure scaled up. So pretty impressed with that. But that's pretty much it. It allows you to tune through and do some fun things. And there is some more, like you can set policies and do alerting and things of that nature in here. So again, you can create those alerts for malware, things of that nature. Get those out to Slack, Jira, Teams, email. There's a lot of different options through dependency track to do a lot of that kind of stuff, and it's pretty self-explanatory. But yeah, that's the tool. I hope people find it useful. My GitHub does have an issue tracker. So if anybody has feature requests, problems, please drop it. At this exact moment, I've tested it pretty well with Mac. I have not done very well with Windows yet because I've got to get that laptop pulled in. But yeah, take a look, and then I also have a blog, and this video is actually going to be attached to that blog. So if you didn't see that first, you can go and read more details on my blog, which is eighpulsniper.github.io, and find out some more information about it. Thank you very much. Happy hacking.